Welcome to the webinar on self-awareness for autonomous systems. Before we start, I'd like to give a very brief introduction to the concept of self-awareness. So self-awareness is a rather broad concept, and it originated from cognitive sciences and psychology. Can you please move on to the next slide? And it has been more recently. It has been then applied to more engineered systems and in a computational context. So self-awareness refers to a system which has some knowledge about itself, and this knowledge is based on data it receives from sensors and also from models, from internal models about the system itself and also about the environment. This knowledge represented in the models can take on many different forms, and as I said before, is based on the perception of sensor data. And it's important to distinguish two different kinds of sensor data the self-aware agent exploits. On the one hand, it exploits sensor data about the environment of the agent. These are referred to exteroceptive sensors. And on the other hand, it also exploits sensor input about the internal state of the system. These sensors are referred to as proprioceptive sensors. And with the data from these types of sensors, the agent is able to reason, to learn, and to act then appropriately in the environment. In order to be functional, self-awareness requires some key reasoning capabilities. They are enlisted here, and they are referred to initialization, which means to get started with some initial model, to provide some initial knowledge and exploit initial knowledge about the system and the environment. It also needs some kind of memorization to be able to store the acquired knowledge. And based on the stored models, a very important capability is inference in order to exploit this knowledge and to reason about the evolution and the current state of this agent and its environment. This is required in order to check whether the perceived data from the sensors is in line with what the internal model predicts. If this is not the case, then we have some abnormally detected, and this then triggers another important capability, namely the generation and the creation of new models, which then better reflect the new situation. And all of that is then exploited for decision making and for exploring the trade-off between different alternatives, how to achieve the final mission of the agent. As I said before, all of that can be realized at multiple and varying degrees and with many different tools. And what this webinar is about, it will introduce to some extent the key ideas of self-awareness for autonomous systems, and which is from our perspective essential for and the basis for achieving truly autonomous behaviors. Okay, so the webinar, as I said before, will address self-awareness from different perspectives. So we have a list of panel speakers. However, we will focus on three main questions throughout this webinar. The first question is about what is self-awareness? What does self-awareness mean in computing and engineering? The second question is about the relationship between self-awareness in engineered systems and in natural systems. And finally, we would also like to address the benefit of self-awareness when we want to engineer, design autonomous systems. And so I'd like to introduce the presenters of this webinar. So the first presenter will be Professor Jeff Drickmar from University of California, Irvine. And he will talk about neurobiologically inspired self-monitoring systems. Jeff is Professor of Cognitive Sciences and Computer Sciences at UC Irvine. The next presentation will be given by Jin Yao. He's from the Southern University of Technology and Engineering in Shenzhen in China. And he will discuss about computational issues in self-awareness. Our third presenter is Professor Nikhil Dutt. He is Chancellor's Professor at UC Irvine, and he's affiliated with the Departments of Computer Science, Electrical Engineering, and Computer Science, as well as Cognitive Sciences. And he will address some hardware aspects. So in particular, how self-awareness can be embodied in computational devices. Our fourth presenter is Professor Regazzoni from the University of Genoa in Italy. Carlo is professor of cognitive telecommunication systems, and he will talk about modeling aspects, in particular, how to exploit signals in order to model and establish self-awareness. And finally, our last presentation is Professor Walter Kellermann from the University of Erlangen-Nuremberg in Germany. He is a professor of multimedia communications and signal processing, and Walter will talk about some applications, some case study of self-awareness, in particular of acoustic processing and sound systems.